told you that one of the most powerful ideas in all of computing, something you literally use hundreds of times a day, is based on, of all things, a simple stack of pancakes? It sounds almost too simple to be true, but believe me, this one concept is the invisible engine powering so much of our digital world. Of course you have, right? We've all been there. That magic little button is basically a digital guardian angel. It saves us from embarrassing typos, from disastrous photo edits, or that heart-stopping moment you realize you just deleted the wrong paragraph. It's our ultimate safety net. But have you ever stopped to think about how it actually works? I mean, it's not just remembering that you did something. It's remembering the exact sequence of your last 10, 20, even 100 actions. How in the world does it keep that history so perfectly organized? Well, the answer is surprisingly simple, and yeah, it has everything to do with those pancakes. Yep, you heard me right. Pancakes, or a stack of plates, or a pile of books. It doesn't matter. This simple, physical idea from our everyday world is the secret key to unlocking one of the most fundamental concepts in all of technology. So what we're talking about here is called a stack. In computer science, it's just a way of organizing data that follows one beautiful, simple rule. Last in, first out. You'll often see it called LIFO, and it works exactly like a stack of plates in a cafeteria line. Think about it. When a new, clean plate is added to the stack, where does it go? On top. And when you need a plate, which one do you take? The one on top. You wouldn't try to pull one out from the middle. The whole thing would probably come crashing down. The last one in is always the first one out. That is the one and only rule. That's the whole game. Okay, so how do we get from a stack of plates to your digital life? Well, you're about to be surprised, because this simple principle is absolutely everywhere, managing everything from your typos to your web history. You are using stacks constantly, whether you know it or not. That undo button in your word processor, that's a stack. Clicking the back button in your browser to retrace your steps online, yep, also a stack. Ever play a puzzle game where you can take back a move? That's a stack remembering your moves. And here's the big one. The very way your computer runs programs is all managed by a stack. So here's the magic trick behind undo. As you type, every single action, every letter you type, every time you make something bold, gets pushed onto the top of a virtual stack of actions. When you hit undo, the computer simply takes the most recent action off the top. It pops it off and reverses it. It's just that elegant. Okay, so now we know what a stack is and where it's hiding, let's dig into the 3 basic moves that make it all work. These are the only operations you need to know. First up, we have push, and it's exactly what it sounds like. You're just adding a new item or a new plate to the very top of the pile. You type a word, that action gets pushed onto the undo stack. You click a link, that web page gets pushed onto your browser's history stack. The opposite of push is, you guessed it, pop. This is just removing that top item. You hit undo, you're popping the last action off the stack. You hit the back button, you're popping the last web page you visited, which then reveals the one that was underneath it. And finally, there's peek. This one's a little different. It's like carefully looking at the top plate to see what pattern it has, but without actually taking it off the stack. It's super useful for making a decision. For example, a program might peek at the last action to see if an undo is even possible before it decides to make the undo button clickable. Push, pop, and peek. Simple, right? But here's the kicker. With just these 3 simple rules, computers perform their most essential and complex job of all, running programs. This is where the stack goes from a neat little trick to the absolute foundation of modern computing. So let's go a little deeper and meet the call stack. Every single time you run a piece of software, this special kind of stack springs to life inside your computer's memory. Its job is to be the master coordinator, to keep track of all the different tasks or functions that are currently running, what they're doing, and where to go next. It's the program's brain, basically. Now, the key to all this is something called a stack frame. Think of it like a little work memo. Every time a program needs to do a specific job, it bundles up all the information for that job into a package, the stack frame, and pushes it onto the call stack. This package has all the data it needs, and most importantly, it has a return address, a little note that tells the computer, hey, when you're done with this task, go right back to this exact spot. And here's how it works in practice. When your program starts, its main task, let's call it main, gets pushed onto the stack. Then, if main needs another task to run, say calculate, then calculate gets pushed right on top of it. Now, the computer focuses only on calculate. Once it's done, pop. It gets popped off the stack. And that return address tells the computer exactly where it left off inside of main. It's a perfect system for juggling dozens of tasks without ever getting lost. So the stack is elegant, it's powerful, but it's not a Swiss Army knife. It's more like a perfectly crafted scalpel. It is amazing for very specific jobs, but you wouldn't use it for everything. Let's break down its superpowers and its kryptonite. Now, don't get intimidated by this chart. This is where we see the true power of the stack. Computer scientists use something called Big O notation just to measure how efficient a process is. Notice that push, pop, and peak all have a time complexity of O of 1. So, what on earth does that actually mean?
It means they are insanely, mind-bogglingly fast. O of 1 means constant time. It takes the same amount of time to push or pop an item whether the stack has 1 item or 1,000,000 items. Why? Because you're only ever dealing with the very top. It's nearly instantaneous. But then look at searching. It's O of n, and that's the stack's Achilles heel.
So here's the trade-off. On the one hand, a stack is simple to build, it's incredibly fast for its main purpose, and it's great at managing memory. But on the other hand, you have zero access to anything except the top item. To get to that pancake at the bottom, you have to take every single pancake off first, which makes it terrible for searching. And if it runs out of space, you get a dreaded Stack Overflow error. And yep, that's exactly where the famous website for programmers got its name. You know, at the end of the day, understanding the stack is about way more than just one data structure. It's a way of thinking. It teaches you to see the flow of information, the sequence of events, and how a really, really simple set of rules can build powerful, efficient systems. And that's the thought I really want to leave you with. The stack's last in, first out rule is so profoundly simple, yet it's a cornerstone of our digital lives. It kind of begs the question, doesn't it? What other elegant, simple rules are out there, hiding in plain sight, quietly running the world all around us?